Hello viewers, we are going to consider implicit differentiation, and under implicit differentiation we are going to consider this problem. Given y equal to sine 3x minus y cubed cos x equal to minus 4, and we've been given an initial condition of pi over 2 comma 5. So what this initial condition implies is that x is equal to pi over 2 and y is equal to 5. And so because we cannot differentiate this directly, we differentiate it implicitly. And so we have solution. We have solution. So we are going to apply product rule in differentiating these functions. I'm going to apply product rule. So the first, we are going to keep y constant and differentiate this. I said product rule, we keep y constant and differentiate sine 3x, plus we keep sine 3x constant and differentiate y. So let's implement that, and we do the same thing to this. So we keep y first constant, dot means multiplication. If we differentiate sine 3x, we are going to have 3 cos 3x. I've done a video on how to differentiate trigonometric functions, and so you can view or watch the video. Plus, it is now time for us to keep sine 3x constant and differentiate y. Note when you differentiate y, it will give us 1 dy dx, or simply dy dx. Okay? Minus, we have to put it in brackets because we are going to do a lot of things here. Minus, we keep y raised to power 3 constant, and we differentiate cos x. If we differentiate cos x, it's going to give us minus sine x, plus we keep cos x constant, and then we differentiate y raised to power 3, and this will give us dot 3 y raised to power 2. And note, whenever you are differentiating with respect to y, you add dy dx. We close our bracket, equal to, this is minus, for when you differentiate a constant, that will give you 0. Okay, and so at this point you can say y times cos 3x. Okay, y times cos 3x will give us 3y cos 3x plus sine 3x. This dot means multiplication times dy dx, so that will give us sine 3x dy dx. And so we can use, okay, let's say minus into this times this, y cubed times minus sine will give you us minus y cubed sine x, that is this multiplying this, plus this times this will give us 3y squared cos x dy dx still equated to 0. Okay, we go over it again. So we are going to have 3y cos 3x plus sine 3x dy dx. So we can now use this negative sign to open this bracket. So when we say this negative times all of this will now give us plus y cubed sine x. And so this negative times this one will give us minus 3y squared cos x dy dx equal to 0. And so we've gotten that. So if we look at the equation, we have some like terms. We can group this and this together, while we take these ones to the ones without dy dx to the right hand side of the equation. This one is without dy dx, so we take it to the right hand side of the equation. This one is without the y dx. We take it to the right hand side of the equation, and then the values with the y dx, we keep them in the left hand side of the equation. So let's start with the values with the y dx. This one is with the y dx, so we are going to have sine 3x dy dx. Okay, this one is minus, so it's going to be minus 3y squared. We are talking about this cos x dy dx equal to, we are done with the ones with the y dx, so the ones without the y dx, we move it. So if we are moving 3y cos 3x to the right hand side of the equation, because it's positive here, so it's going to be negative over there. So we have minus 3y cos 3x, and so we also move this one without the y dx, this one y cube sine x, because it's positive, it's going to be negative in the right hand side, so I have minus y cube sine x. Okay, I haven't done that. Since this is common here and it's also common here, we can factorize, and so when we factorize, we have the y, the x, as we bring out the y dx, and then if we bring out the y dx from this, we are going to be left with sine 3x minus, if we bring out the y dx from here, we are going to be left with 3y squared cos x. So this is equal to minus 3y cos 3x minus y cube sine x. Okay, we've gotten that far, and so I think okay, now because we are looking for the y dx, we have to, since we are looking for the y dx, we have to divide both sides of the equation by any variable or function that is close to the y dx, so that the y dx can stand alone. So we make this mathematical statement: divide both sides of the equation by sine, okay, let's put it in brackets, sine 3x minus 3y squared cos x. So we are going to divide both sides of the equation by that. Let's use this part of the board. And so when we implement that mathematical statement, we are going to have dy dx, okay, into sine 3x minus 3y squared cos x divided by sine 3x minus 3y squared cos x equal to, we come to the right hand side, what we have is minus 3y cos 3x minus y cube sine x divided by this sine 3x minus 3y squared cos x. And so this can cancel out this, so that we are left with the y dx equal to minus 3y cos 3x minus y cube sine x divided by sine 3x minus 3y squared cos x. And so remember that we have been given initial condition here, that our x, we have pi over 2 comma 5, and I said it means that x is equal to pi over 2 and y is equal to 5. And because we are dealing with angles, pi here equals to, the value of pi here is 180 degrees. So it means we are at this point we substitute the value of x and y into this equation. And so when we do that, we are going to have minus 3. What is the value of y? 5. So we put 5 there. Cos 3 into, what's the value of x? X is pi over 2 minus y is 5. We are dealing with this one raised to power 3 sine. What's the value of x? X is pi over 2. Okay, let me write it properly. Pi over 2. Let's put it in brackets. Divided by, so we come here, we have sine 3 into x is pi over 2 minus, okay, we are looking at this one, we have 3, the value of y is 5 and it's raised to power 2 cos the value of x is pi over 2. Okay, we've gotten it to this point. Okay, let me use this other. Okay, I can use it. So we have that minus 3 into the value of y is 5 cos 3 into the value of x, and we've established that our pi is 180 degrees because we are dealing with angles, trig ratios. So that is it. So let's move over to this side of the board to complete our solution. And so let's bring out the value. So from here we have that the y, the x will be equal to minus 3 into 5 cos 3 into, our pi is 180 degrees divided by 2. We are dealing with this minus 5 raised to power 3 is 125 sine into pi is 180, so we say 180 divided by 2. We are done with the numerator, divided by 2. We are done with the numerator, so we go to the denominator here. So we have sine 3 into pi is 180, we say 180 divided by 2 minus 3 into 5 squared is 25, that's 5 times 5, cos into pi is 180, and we have divided by 2. Okay, now having done this, we continue. 3 times 5 is going to give us 15, so we have minus 15 cos 3 into 180 divided by 2 will give us 90. This is 2 here, 1, 2 here. Okay, 2 here, 1, 2 here, 9 into here, 0, 90. So minus 125 sine into 125 sine into 180 divided by 2 will give us 90. This is 190. So we are done with the numerator. We now go to the denominator that we have sine 3 into, this is 1, this will give us 90 minus 3 times 25. 3, this will be this times this is 15, carry 1, 6, so 75 cos this one here is 90, cos 90. Okay, so we've gotten that far, we're still progressing, and then we have that this will be equal to, we know that cos 90, okay, this will be minus 15 cos 3 times minus 15 cos 3 times 90 will give us 270 minus 125 sine. The value of sine 90 if we find sine 90, the value of sine 90, if you punch your calculator, is 1. So we have times 1 divided by sine 3 times 90 will be 270 minus 75 cos 90. If you punch cos 90 in your calculator, that will give you 0. And so this will be equal to, again, cos 270, okay, this one will be minus 15 times cos 270 is 0, minus, we have this 125 times 1 is 125 divided by sine 270, if you punch your calculator, will give you 0, minus okay, sine 270 will not be 0 times 200, sine 270 is 1, and then minus 75 times 0 will give you 0. And so from here you have your dy over dx to be equal to minus 15 times 0 is 0, 0 minus 125 will give you minus 125 divided by 1, will give you minus 125 divided by 1. Oh, sorry, sine 270 is minus 1, so this will be divided by minus 1. So you cancel out this so that your dy dx will be equal to 125. Thank you.